Hello, this is Jack Jackson. In this video, we're going to put in a function, program a function on a TI-nspire CAS that will compute numerical integration. It will do left, right, trapezoid, midpoint, and Simpson's rule estimates. And I'm going to do this by way of making use of a matrix. So I'm going to start there. Let's see. I need two columns, and I'm going to need one for the function A, B, and N, and then I'll have the left, right, trapezoid, midpoint, and Simpson's rule. We're going to do a calculator approximation and a calculator exact value. So there are going to be 11 rows to this matrix. So go to Menu, Matrix, Create a Matrix. I want 11 rows and 2 columns. And with the So, by the way, you can see the keypad over here for the TI-nspire CAS. The screen is normally above that on the handheld, but the screen is blown up and moved over here to the side. So, anyway, we have our matrix, and we're going to be able to put in text here. So, for example, here, I'm going to put quote A, and it should put the actual text for A there, and we'll put the value of A over here. We'll have the same way B here, and then the value of B here, N here, and the value of N here. Okay, we're going to have f of x here, and then we're going to put the formula f of x over here. Here we're going to have, let's see. You know what? I think I'm going to make that f1 of x, and that will be in a standard graphing menu when we do that. No, I'm just going to make it. I take it back. Sorry, I'm just going to make it f. Okay. Now we need to figure out. So this is going to be ln in quotes. This is going to be, again in quotes, right, N, trapezoid N, midpoint N, Simpson's 2N, approximation to the limits of the calculator, and the integral. The actual value, exact. Here. Okay, so for the exact integral, I can actually put this in. It's going to be the integral, definite integral right there, from A to B of whatever f of x is, dx. And the approximation is going to be approximate, well, copy that and paste it there. For the left Riemann sum, I can actually use a sum. So I can go here and use the sum. Actually, I want to put the delta x out front. So we'll start with that. It's b minus a over n. And I'm going to use index k, so k goes 1 to n. And then what I would need to do is just do the y values here. So it's going to be f of, well, it's a plus k times parentheses, and that parentheses goes delta x, which is here. Actually, it's for a left Riemann sum, it's k minus 1. For a right Riemann sum, it's the same thing, except this here is just k. For the mid Riemann sum, it's the same, except this is k minus a half. Now trapezoid is going to be left plus right divided by 2. I can factor out this b minus a over n. and I'm going to divide by 2, so I'm going to make that over 2n. And then in this parentheses, I'm just going to take what I had for this sum here plus what I had for this sum here. Okay, and now Simpson's rule, I'm going to I do 1/3 of, well, it's 2 times parentheses, and in this parentheses is going to go this, the midpoint, plus, I'll put parentheses, the trapezoid, which was, what was it? This one right here. The whole thing. Copy that. Paste it here. It's maybe not the most efficient way to do this, but this should, I think, work out correctly. Now, when I'm done with this, okay, I want to store that, and I want to name a new function. In numerical integral of, and what do you have to pass it? You have to pass it f of x, a, b, and n. Now, if I did this, we'll see if this is going to work. Hopefully this is going to work out. Argument must be a variable name. Okay. So I think I can get just f here. It should be okay. Okay. So let's see if this works. So now I can get that by, if I remember the name of it, I can just type it in. But I can also hit variables here, and it'll come up. So let me check something out here. I've got one that I've already done. We'll see if this works. So if this is x to the 5th, and we're going to integrate from, let's say we're going to integrate from 1 to 4. And we're going to do it with, say, 10 subintervals. Let's see if this is going to work for us. It doesn't like part of this. Which part did it not like? Okay, let's try something here. Okay, so that did not like it. So let me change this. Okay, so okay, let's just always use F1 for this, just like I did on a TI-84. So we'll just make this F1 each time. Okay. So let's do F1. Let's do F1. right. Here's another one. Okay, let's see if this works better. So now I'm only going to pass it as A, B, and N. Okay, so now to run this, the first thing I need to do is take my formula and store it. X to the fifth, store it as F1, and this will be the thing that's in the graphing menu. So if I hit graph, it will be graphing this. And now let's go up and integral, and let's do from 1 to 4 with 10. Let's see if this is going to give me what I want. Yeah, let's see if this works out. Oh, it gave me decimal approximations too. Okay, I mean, it gave me fractions instead of decimal approximations. So probably better if these were approximations, decimals. Okay, so let me go back to here. Well, one thing I could do is just take that answer and just now say, take that answer and approximate it. Let me see, I've got something that's telling me what these things should be, and I'm just double checking to make sure everything's working out correct. Yeah, it works out great. That's correct. But I think it'd be better if we just forced it to do approximations from the beginning. So let's do that. Let's go back up here. Okay. That's not the one I want to get. This is the one I want right here. Let's see if I got that. All right, let me get this. Get this whole thing. There we are. Now I think I've got it. And let's go down here. I'm not sure if I got the right one. I want this one. Yeah, the ABN. That's the one. Okay. Okay, and now what I want to do is go back now. Make sure these are approximate. And the way to do that is put approx. So for each of these things, I'm going to put approximate in front of it. And it should approximate that whole thing. Alright, let's see if this works out like I want it. Alright, so now if I hit this, let's say we want to take this again, let's do the same 1 to 4 with 10 intervals. There's the exact value in fraction form. There's approximation decimal, which is actually in this case exact. And these are the approximations for left, right, trapezoid, midpoint, n, and Simpson's 2n for that particular one. And it does also, let's see, shows us n, a and b, and it shows us the formula that we're integrating. So it shows us all of that right there. Okay, so that's it. So all you have to do is, once you finally get it in. So this is what you put in. Remember, it's in quotes what we want listed there. And then here's going to be draws from F1. So to run this, you need to have your formula in F1. Here we have A and B and N. It says approximate B minus A over N times the sum from K equals 1 to N of F1 of A plus K minus 1 times delta X is B minus A over N. Same thing here with just a K instead of K minus 1, so that'll be at the right end. One for midpoint's the same with K minus a half right there. There it is. There's the midpoint. Trapezoid, I just took these two, added them together, and multiplied by half. I was able to take the B minus A over N factor out front and put that B minus A over 2N out front. And again, I wanted to approximate that. And for this one is I used 2 Simpsons. For Simpsons, I got 1/3 of, this is 2 of the midpoints, and this is plus 1 of the trapezoids. And I stored that as a numerical integral of a, b, n. So now that's a function. As long as you're in this particular document, you'll have that particular function available to you. So let's do another one just for practice. Let's do this one. Let's take the function 4 let's say e to the power x squared something we can't do an antiderivative of with elementary functions. So let's store that as F1. Of x. Okay, and then we can run that thing here, numerical integral. Let's say we go from 3 to 11, for example, 3, 11, and then let's do it with 10 intervals again. And this is what we get here. Notice these are times 10 to the 53rd. These are really big things. This thing grows very fast, so by the time you get up to power 11, this thing is way up there. So anyway, that is this is the calculator approximation to the real thing. This is the approximation there. So these agree. These are both 0 to many places, so they actually agree quite a bit. But we can get a better estimate if we would choose a bigger n. So in any event, there you can find it. You can do these pretty easily. You can, if you wanted, you could do maybe a little bit easier by doing just some of these sums, but this finds all of those different sums. All right, you can see how to use that. Bye-bye.